Excuse me for a second. Okay, so good afternoon, everyone. So welcome to lecture 24 on circular queue using array. So I have shared my screen. Hope you can see my screen. Am I audible properly?
Yes, sir.
Yes, sir, you're audible.
Okay. So you have so far seen how does an array look like. So this is an array and its orientation is linear like this. Okay, so it's like a wire, straight wire. Now if I bend the wire to form a circle, it will look like this. These ends and these ends are joined. Okay, so if I bend the wire in terms of a circular loop, it will look like this. But still, the arrangement is not a circular, it's a linear. Still, it's a linear, right? But as it is looking like a circular loop, so we can call it with a different name, something circular. Okay, ঠিক আছে? Something circular. Now, if I implement a queue
Acha,
using,
sir, one thing.
yes,
Sir, linear mane, sir, you mean, sir, unidirectional? Man, in single direction, we are following the path.
no, it's not about the direction, it's a line. Okay, the shape you can say.
Okay,
It's
okay.
a line. Now, if you consider this line to be a wire, I can bend it. So if I bend that wire to form a circular loop, it is forming another different shape, which is a circle. Okay, so but both of them are linear data structure.
Okay, okay, sir.
So these are two data structure. This is array. This is also array. Okay, so if I bend this array to form a circular loop, it will look like this. So this is a data structure. Data structure means some a kind of an
It's
entity.
arrangement of data.
Yeah, some kind of an entity where you are storing some data, and with the and according to some scheme. Okay, according to some principle, some policy. So here this data structure is known as array. Some data structure is known as structure. Some data structure is known as linked list. Okay, so these data structures are based on their own principle or policy. Array does have its own policy. Here you can't store dissimilar type of data. You have to store similar type of data. Their data types should be same. That is the policy. We can't do that. Based on this policy, this data structure has been introduced and defined. Next, linked list, it is having its own policy. Okay, in linked list, memory allocation of different locations may not be contiguous. They can be uh, they can be scattered. Okay, throughout your memory device, RAM or ROM or external hard disks, whatever. ঠিক আছে? So these data structures are having their own schemes. That is different issue. But the data structure is actually uh, linear, and some data structure is uh, non-linear, that can be easily understood if you consider the traversal. So if you go for the traversal, you will traverse like this. If you go for the traversal here, you are going like this. First this, next this element, next this element, here. First this, next this, next. Okay, so it's a linear. Now, if you have something like this, okay, so this is a graph, okay, connected graph. So this is not a linear data structure, you can say. So if I go for a traversal, then see, if I reach this node, I am having 1, 2, 3, 4 branches. So 4 options I am having. I may go to this way, or this way, or this way, or this way. So this is something you can't have in case of this. So whatever data structures you have understood and learned in linear data structure, like array, linked list, stack, and queue. Queue may be linear or circular queue, whatever. Okay, that means in one way you can say that from an element, from a location, you can't have multiple paths available, multiple branches available to move forward. Okay, which you can see in case of graph. In case of tree also, you can see that. This is simple, a binary tree. So I am here, but I am having two options. I may go in this way, or I may go in this way. Okay, so this is something. But yes, if you start from here, okay, let me introduce two more children, because if you consider this much, it is not telling us that it should be a non-linear. It's a tree representation. That's why I am saying that it's a non-linear. But if you start from this node, you can travel and finish over here. Then it is looking like a linear data structure. Okay, though
Yes, sir.
the shape is like this, but it's a linear data structure. Okay, but yes, from this representation, we may not understand whether it's a linear or non-linear until we have a prior information that it's a tree. So suppose this is a tree representation. This is. Now here you can't have a linear propagation while traversal. Okay? So if you start from here, you are reaching here, then you are having two options. Either you can go over here or you can go over here. So this is the thing. Anyway, so this is the array. Suppose you have already done linear queue using array, and now we are today understanding the circular queue using array. And this is the only difference. You are bending this array to form this circular kind of loop. Okay, but ultimately this is an array. Okay, physically you are not actually bending the array arrangement to form a circular thing. It's just a concept. How can you visualize this memory representation? Memory are oriented like this. Its address is 800. Let's say this is 8001. So memory arrangement, computer organization, it comes under the subject computer organization. There you will also you can have a flavor of memory arrangement. Are you studying microprocessor 8085 in this semester?
No, sir.
Okay, so probably in the next semester you will be studying about as a computer architecture you are studying, right, in second year?
No, sir.
Sir,
Ramesh sir,
till now we have not studied.
Ramesh sir কি পড়াচ্ছেন?
Sir, fourth semester, এই সেমিস্টারে নেই।
ও আচ্ছা, কম্পিউটার আর্কিটেকচার। তোমাদের ক্লাস নেন না সেকেন্ড ইয়ারে রমেশ স্যার?
স্যার আপাতত নেই এখনো।
আচ্ছা আচ্ছা, okay, then probably in the next semester you will be studying microprocessor, and there you will know about memory addressing. While learning memory addressing, you will come to know about how memories are being oriented. Memories are oriented, they are organized. Okay, so this is like, okay, stack, okay, and then stack in a single page, then some pagination, one page, second page, third page, like that. So this is the smallest memory unit, 8000, for example. Next address would be 800, let's say 4, 8004, next 08, and so on, and then 1 2, and so on, dot dot dot. Here also, this is the address 00, 8000, then 04, then 08, then 1 2, then 1 6. Okay, sorry for the background noise. So 20, then 24, then 28, like this. Okay, but that means what? The memories are contiguous, so it's like an array, and array is a linear data structure. So that's it. But we are visualizing the orientation in the form of a circular loop, but it is not physically done like this. Okay. Okay, so circular kind of memory arrangement does not exist. Okay, so this is just a concept. This is only for our visualization. So how can you make this convert this line into a circle? Nothing, just you have to make a connection like this. Means after this memory unit, you must, if you go for the traversal, if you go for the traversal, let's start from this memory unit, this element. Next you are going here, next here, next here, next here, next here. Once you are reaching this element, next you have to go back to this element, and that is the idea of the circular queue. You have to provide something extra so that you can go from this element to this element as the next. Okay, that means the two ends are not open, they are connected now. Okay, this is the extra thing which we have to do in case of circular, otherwise it's correct. Now if we have to do that, now what should be our implementation, code implementation, what should be the logic? Okay, so those things we have to understand here. Okay, okay, so let me so as per the policy, a queue should have two pointers, front and rear. So here also I'm having two pointers, front and rear, somewhere rear. Okay, rear. Okay, so let me remove their addresses. Okay, so initially, let's say uh, front and rear are pointing towards nothing. Here it is null, rear equal to null, while you have done linear queue using array. Here also front and rear are pointing towards nothing. So in many ways you can implement the circular queue using array. You can take these two pointers, front and rear, as integer variables. You can take them as pointers, okay, and also or right, ঠিক আছে? And then you can also implement the code of circular queue using linked list. We are today understanding circular queue using array, but yes, you can practice the same with linked list. Okay, so in theory class we are studying this circular queue using array, but in practical I will ask you to implement circular queue using linked list, just for your practicing. Okay, so let's start the code a little bit. Okay, so let's say this array index starts with 0 and that zeroth element is this one. Okay, 1 2 3 4 5 6 7 8. 4 5 6 7 8. I'm lucky. So this is 0. Okay, right. Now, yes, okay. Okay, so this is the arrangement. And what are the operations we want to do? The operations are like insertion and deletion. Yes. So we will try to insert some values. Let's say 3, then 6, then 12, and then 20. Okay, then -5. So these many numbers we want to insert. Let's say. Yes. And accordingly, we will develop the logic and code, and you will try to write algorithm at your home. Okay, so these 3 should be stored here. That is our expectation. How can we do that? So initially we have to take front and rear as pointers. So I am taking front and rear as pointers. So I can take them as a global pointers, because if I uh, develop other functions, so those functions need to access those front and rear pointers. So they must be globally declared. So pointer declaration is something data type, and then star front, and then star rear, right? But what kind of front and rear pointers they should be? So what they are supposed to point? So they are supposed to point towards these locations, right? So these locations contain integer kind of values. For example, what kind of array is this? What kind of data this array should store? So let us globally declare an array int CQ, and let's give it some size capacity n. So okay, let's keep this simple. 10, 8. We have taken 8. Okay, so this is that array which is to be used to implement the circular queue using array, or more precisely array memory allocation for circular queue. Understood? Okay, so this front and rear are supposed to point towards these locations, and in those locations the values stored are actually of integer data type. So immediately you understand that the data type of front and rear should be int. So we are declaring int star front, int star rear in a single. ঠিক আছে? You got it? Point.
Yes, sir.
Next, so next it is we want to create a menu option. Display. Okay, so then switch. So this case is for insertion. Here you want to call a function. Let's say a function, and then break. That's it. prototype declarations are done.
सर अपनी ऑप्शन वेरिएबल है ना
And oh, okay. So I'm now error free. My structuring of the program is done. Now so here I have to know ask the user to provide the value of the data to be inserted into the circular. Okay, that value I want to pass, okay, to the function call as argument, right? And that value is coming here. So someone has to receive that, let's say int value. Okay? That value has came here. It is available to the body of the insert CQ function. That's fine. Let's say that value equal to 3. Let's say for the first time this value equal to 3. Now you want to store over here. Now who will help you to store the value 3 in this location? So as you have done linear queue using array, you have used the pointer rear for insertion purpose. Similarly, we will do here. So we want to use the rear pointer. So I want to ask the rear pointer, please take me to the desired location where I want to insert the value 3. Then the rear pointer is supposed to point towards this location, right? Somehow. And then using the rear, I want to put that value 3 in that location. Wait. 1 second, again type.
স্যার
হ্যাঁ বলো।
স্যার বলছি ইনিশিয়ালি ফ্রন্ট আর রিয়ার কি নাল থাকবে নাকি অ্যারের ফার্স্ট
Yes,
এলিমেন্টটাই
as
থাকবে?
we have taken front and rear as pointers, so what I am supposed to do that just after the declaration, I want to do front equal to rear equal to down. Okay, these are pointers. Okay.
স্যার
Next,
বলছি যে ওটা কি নাল থাকবে নাকি অ্যারের ফার্স্ট এলিমেন্টটায় পয়েন্ট করে থাকবে?
করতে পারো, সেটাও করতে পারো, বাট তার একটু ছোট্ট এদিক ওদিক মানে একটু ঝামেলা হতে পারে, একটু প্রবলেম হতে আসতে পারে। যখন তুমি ওভারঅল অ্যালগোরিদমটাকে যখন তুমি র্যাপ আপ করবে, ফিনিশিং টাচ দেবে, তখন দেখবে একটুখানি সমস্যা হচ্ছে। তো এইটা একটা ইনটিউশন প্রবলেম হতে পারে যে I may initialize front and rear with null, or I may do front equal to rear equal to the address of this zeroth location of the array. So let's see. So let's start with this front equal to rear equal to null, and then try to understand what will happen. So what I want, so front equal to rear equal to null, right? So with the help of rear, so the rear is pointing towards null, right? Now how is it will be possible that rear will be pointing towards the zeroth location of the array where 3 should be inserted? So you can do that here, rear equal to ampersand CQ0. What is the name of the array? CQ. So if you do this, rear equal to ampersand CQ0, then rear will point towards zeroth location of the array.
স্যার রিয়ার তো সবসময় লাস্ট নোডটাতে পয়েন্ট করে, মানে লাস্ট এলিমেন্টটা।
রাইট, এখন তো কোনো এলিমেন্ট নেই, খালি। তাহলে যে এলিমেন্টটা তুমি স্টোর করবে সেটাই ফার্স্ট আর সেটাই লাস্ট, ঠিক আছে?
আচ্ছা আচ্ছা স্যার।
সেগুলো ঠিক আছে। Now next what I want, rear equal to value. So rear is a pointer, so what we have to do, star rear equal to pointer value, ঠিক আছে? Star rear equal to, if I do that, star rear means, what is the meaning of star rear? Star rear means value at the address which is specified by rear. So what is the address specified by rear? Rear is pointing towards this. That means rear is equal to the address of CQ0, and inside that address, whatever the value, it should be equal to 3. That is the right hand side. That should be equal to the value. That means 3. So this means value at that address. Which address? The address specified by rear. What is the address specified by rear? The address of zeroth location. So the value at zeroth location should be equal to value. What is value? 3. So in this way, 3 value is being stored in this position. ঠিক আছে? So have you understood this portion?
Yes, sir.
Yes sir.
Okay. Now you try to insert next value 6. Then you will have a problem. Okay. So it is done. 3 value has been stored over here. So return 0 means from return 0 it is coming back to this line. So it is a break. Break means from case, switch case it is breaking. Switch case it is coming over here, and then it is going again while. Again insertion, deletion, display, exit. So you are pressing insertion, Okay, let's try to display the circular queue. We have inserted a value and I want to see whether this 3 value has been stored in the circular queue properly or not. So let's try to do this display. So if I want to display with the help of front and rear, okay, next many things are to be done here. Rear is pointing towards this, fine, but what is the job of front? It is supposed to point towards the first element present in the circular queue. So, and as this is the first element in this situation, so front should be pointing towards this location. Okay, so how can we do that? Front equal to, there are many things, ampersand CQ0, or you can do front equal to rear, whatever you are confident. Both of them will do the same thing. Rear equal to this, front equal to this. Okay.
স্যার
Hmm.
স্যার বলছি এটা তো only for the first case when there is no
Yes,
element
I'm coming.
present.
I'm coming. All those. Actually, I will update all this code. No issue. Okay. So I'm starting from the very fundamental.
হ্যালো স্যার,
হ্যাঁ,
ফ্রন্ট রিকয়েল রিয়ার করলে রিয়ারটা যখন মুভ করবে ফ্রন্টটাও তো মুভ করবে।
মুভ কোথায়, এখন তো করাইনি, এখন আসিনি, ঠিক আছে। ওকে, স্টেপ বাই স্টেপ ডেভেলপ করছি ব্যাপারটাকে। ওকে, তো এই গেল কেস। তাহলে আমার এই সিচুয়েশনটা তৈরি হয়ে গেল, তোমাকে বলা হয়েছে এই সিচুয়েশনটা তৈরি করো, তো আমি করে দিয়েছি। এবার আমি ডিসপ্লে করতে চাই এইটুকু, তাহলে আমি ডিসপ্লে করতে চাইছি, তাহলে with the help of front and rear I want to display the circular queue. So if I start from front and end with rear, it is supposed to display the content of the circular queue, right? So I need, and front and rear are pointers, so I need a pointer, integer, int star, traverser. Okay, so traverser should be initialized with front. So I am starting with front, and then I am using a loop where with the help of traverser I want to display the content. So printf %d star traverser, that's it, until traverser is this should be going on
less than equal to হবে এখানটা।
traverser less than equal to তোমার হচ্ছে rear,
rear.
but when it is greater than rear, it should stop. So I have to provide here such a condition for which this loop will be continuing, and the loop should be continuing for this case. So that is the required condition. Okay, that's it. You can display a message, beautiful message. Okay, so here int value, here also you have to do the int. Let's compile, no error. One, enter the data to be stored, 3. Display, it's an infinite loop of 3. Front equal to ampersand CQ. Oh, traverser is not modified. Oh. Now it's fine. So circular queue, the contents are 3, 3. Okay, so I am satisfied. Whatever I have done so far, I am good at that. No issue. Now let's come back to the insertion. So this is successfully done. Next, we want to insert the 6. So insertion. Here the program control will come under this case. Enter the data to be stored. So value equal to 6. Insert CQ function will be called. So now value is equal to 6. But as for the code written over here, the rear is equal to ampersand CQ 0. So rear is pointing towards this, and then star rear equal to value. So 6 is being stored in this place, replacing the older value. Okay, so this is undesired. What we are expecting now, we are expecting something.
স্যার যদি স্যার লাইন নাম্বার 43 আর 44 কে যদি একটা লুপের মধ্যে রাখা যায়, ফর লুপের মধ্যে, আর স্যার রিয়ার ইকুয়ালস টু সিকিউ অফ আই, মানে যদি স্যার ফর লুপটাকে যদি আই দিয়ে করি, দেন স্যার হতে পারে।
No, that is not required. That's a different thing. So I wanted something like this. Actually, I am presenting you the filling. What should be the filling? So this is important now. The rear should move on to the next location. Rear should point towards this location. It should not point towards this location. Okay. Right? Rear should point towards next. So how can I do that? Rear plus plus. Now you require this line rear plus plus. Why? When it is coming into the picture. Now already you have understood my point that rear plus plus is essential when there is at least one element in the circular queue. It is not empty. So rear plus plus is required for non-empty case, and rear should be equal to ampersand of CQ0 when the circular queue is empty. So these two lines are conditional lines. Okay, so if the circular queue is empty, then I should write this line. Okay, let's say all these lines are here. Let's say if that is okay. I don't know which lines we have to write, but for the time being, okay. So let's assume that if circular queue is empty, then these 3 lines should be done. This is for sure. This is for sure. But whether these 2 lines should be coming under circular queue empty case or not, we will shortly investigate that. Now here we have already come up to this point else. In else part, this should be there, isn't it? Am I correct? Kilo.
Yes, sir. Yes.
Yes, sir.
So this is queue is non-empty. Non-empty means at least one element is there. Non-empty, more specifically, okay, non-empty for the time being, non-empty. Rear plus plus. So if I do that, then rear will move towards next location, and then I can store that value 6 using rear. That means star rear is equal to value. Okay. So by this 6 is stored, but front should not be moved or updated. That means front equal to ampersand CQ. That is valid for this case when circular queue is empty. That line should not be under this case. Front is correct. Front is pointing towards 3. That is fine. But rear is changed to now 6. Okay. So now, if this is done, so let's try to compile. Okay. Oh, we have to now provide the condition. Now, how can we provide the condition that to check whether the circular queue is empty or not?
rear equals to null.
So
দুটো
one
স্যার নাল দিয়ে চেক করলে
had already that front equal to rear equal to null when the circular Q is empty. Okay? So that thing we can use over here. Front equivalent to null or rear equivalent to null. Okay. Let's try to do this. Display, it's fine.
স্যার শুধু ফ্রন্টটা দিলে হতো না?
It is correct. So whatever we desire that is happening, we will shortly do update the program. This program is not actually completed as of now. Okay? So code will be more updated. So this is the case. So that means if I now proceed further, if I want to store 12, 20, minus 5, and all of them will be correctly stored in proper places. So let's do that and verify. Insertion data 3, insertion data 6, insertion পরেরটা কি ছিল 12 20 minus 5. So 12 20 then minus 5. Now display and correct. So 3 6 12 20 minus 5. Okay, so we can't put dashes in the printf. Okay. So this is the case. So insertion is okay, no problem with that. Now the code should be updated whenever deletion operation comes into the consideration. And again, one thing we can do here, little bit of code optimization. This line is common to both if and else part, so we can do that part here. Okay, so we can remove that thing here, right? And still the code is very fine. Right, it's fine. Pin dash can assume. Yes. Now let's consider the delete. Okay, so if some values are stored, 12, 20, minus 5, right. And where is the rear pointer pointing towards? Rear is pointing towards this. Okay, so front to rear you are displaying the circular key. Now we want to delete some element, and you know whatever the element the front pointer is pointing towards, that should be deleted. So 3 should be deleted here. Okay, so if I want to delete 3, so that means this user has pressed the option 2, the function is called. So here is the definition. So here we want to write the code for deletion. Okay, so 3 should be deleted. 3 should be deleted means what? What is the logic? Front should be moved towards this location. As it is a circular cube, and you can see in this code implementation, the index of the arrays are not being used at all. Are they used anywhere? Only in this case, CQ0, and that is the problematic situation. Okay, so if you move the front pointer to the next location after deleting 6, then in some case this portion of the code will not work. Okay, let's see. We will handle that situation later, but let's try to consider the simplified version. So we want to delete 3. How is that possible? Delete 3 means what? Uh, uh, how can you delete? I mean, in array, that is the disadvantage. You can't do memory deallocation for this location, this memory. Okay, so simply you can move that pointer from to the next. Or another concept, already I told you that don't remove the front, you just rotate the circular queue, rotation, I mean shifting rotation. Okay? So you are shifting 6 here, 12 here, 20 here, minus 5 here. That is also you can apply, no problem. But let's say we want to move the front pointer to the next location. Okay, so what will happen? So let's store the data first. If I want to, if I may want to use that deleted data in some purpose, so let's store the data. So deleted data. Deleted data is equal to star front, and then you do front plus plus. Okay, but this is this assumes that you have a non-empty queue. There are some elements. Okay, so then what is happening? This is lost. Front is pointing towards this, and 3 is still there. It is not deleted. But this is lost its own connection. You are not you will not be able to access this element. Okay, so that is the idea. Anyway, next you want to delete 6. 6 means delete queue function will be called. So here it is coming again, int deleted data equal to star font. I am storing the deleted value into some variable. So then what is being done? Front plus plus. Front plus plus means it is now pointing towards this. Right? That means it has lost its connection. Now at this moment, if I want to display the circular queue, it will correctly display starting from 12 and ending up with -5, and that is correct. Yes, sir.
Yes, sir.
Okay. So I can keep going on deleting element 3, 6, 12, 20, -5 like that. So let's see what happens. Let's see. Let me bring that situation. These are the circular queue elements, and then delete. Let's display. See, this is displaying 6, 12, 20, -5. So deallocation is not happened. 3 is still there, but we are not able to access it. So then to delete again, display. You can see 12, 20, -5. You can keep going on, no issue. Okay, you can still keep going on, no issue. Aha, there I did the mistake. See. Okay, so all the elements were deleted, no issue. All the elements were deleted in the picture. What is happening? These are deleted. Okay. Now at this situation, where is the front? Where is the front? So after deleting 6,
Sir,
front
rear,
12.
rear position at last.
No, 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 no. After
The
deleting 6,
behind
front has moved to this. After deleting 6, front has moved to 12. After deleting 12, front has moved to this location. After deleting 20, front has moved to this location. Okay. After deleting -5, front has moved to this location.
rear +1.
Okay, okay.
These are the concepts we have to very carefully observe and understand. And that's why I wanted to present like this. Let's suffer the problems, then we will understand what are the problems may arise so that we can fix. Okay, so this is the scenario. Front is pointing towards this location. So all of you have understood this portion, I guess. Okay. And at this situation, what is your expectation? The circular queue is empty, yes or no?
Yes, sir.
And in your code, you have used a condition that front equal to null or rear equal to null to check whether the circular queue is empty. Now, is it safe, this condition? So at this situation, see the picture, the circular queue is empty, but rear is pointing, not pointing a null, it is pointing towards an address. Front is
স্যার
also
আপনি
pointing
বললেন যে ওটা অ্যাকচুয়ালি মানে নাল নয়, মানে এমটি নয় কিউটা, মানে ওগুলো আমরা অ্যাক্সেস করতে পারছি না, কিউতে তো
but
এলিমেন্টস গুলো আছে।
logically it should be like the case. It is not happening that circle 3, 6, 12, 20, -5 is still there, but logically circular queue is empty, and that should be done. That is our expectation. How can we do that? If there is some element already stored over there, it's not a problem, because whenever if I want to access this location and if I do some insertion, the older value will be automatically replaced. So if there is some value already existing, that is not a problem, because eventually it will be replaced by new values whenever you do insertion. Yes. But logically, at this moment, the circular queue is empty. Now we have to do something so that everything will be sustained. Means circular queue emptiness should be sustained. Yes. What can we do here? So when this situation arises, what can we do? We can
স্যার একটা
reinitialize front to null and rear to null. This thing we have to do separately. When circular queue will become empty, and how will you know that this situation arises when circular queue becomes empty? And that is the crossover happening, crossovers. So front is pointing, initially was pointing here, then pointing here, then pointing here, then pointing here, then pointing here. Okay, and after some time, front pointer has crossed over the rear. Means crossover condition means here front has become greater than rear, isn't it? So this is the condition when crossover occurs, means when circular queue becomes empty. So while there is at least one element in the circular queue, this condition is false. Front is always less than or equal to rear. Okay, so while deleting an element, we want to keep a track on this. If front has become greater than rear, that means we have to understand the circular queue is empty. So what we have to do? Front equal to rear equal to reinitialized to null. So this we should have to do. Okay. Front plus plus. Otherwise, it will be skipped. And here you will check before that if front is equivalent to null or rear is equivalent to null, that means printf circular queue underflow, right? And then you have to return. Get it? Should be kept at the beginning of the function. Right. It will return. Otherwise, if condition is false, that means the circular queue is not empty. There is at least one element, and that element will be stored first, then front will be moved, and in some case, if this happens, like this crossover happens, then it will be adjusted by this code. So this is the crossover adjustment. Okay, single line. Okay, so we already did this. They have stored all the 5 elements and deleted all the 5 elements. So let's do that. How can we validate this situation? Let's see. So 3, then 6, then 12, then 20, then -5. Let's display this. Delete it. Right. -5 is also deleted. Circular queue. Oh, okay. It is creating some problem because in display function also we have to write something. Printf circular queue. If front is equivalent to null or rear is equivalent to null, then this thing return 0. Otherwise it will go on traverse equal to font. Right. Okay. Circular queue underflow. Okay. So now okay. So circular queue underflow. That means this situation happened, crossover happened, but somehow this message is being displayed. Why this message has been displayed? Why? Because front has become equal to null or rear has become equal to null. If this adjustment was not done, this message would not be printed. So this is kind of a validation. Yes, now I can keep going on insertion. Right. And there is a storage of 8, right? So I can insert 8 elements. Okay. 6, 9, 12, 15, 18, 21, 24. All the 8 elements are stored. So it is not supposed to allow me to add more elements. It should show at this situation circular queue overflow. So I think that is very easy. But yes, now can you tell me when it will happen? So when the circular queue is is overflow, so then how to check the condition that whether the circular queue is overflow or not? What will happen to front and rear in that case? বলতে পারবে? চেষ্টা করো।
স্যার দুটো কি সেম এলিমেন্টকে পয়েন্ট আউট করবে?
জিজ্ঞেস করে লাভ নেই। You have to be 100% sure about it. You think and be sure. Yes, it could be.
So if rear is pointing to the last element. So if rear is pointing to the last element, that means that.
Are you sure? 3, 6, 9, 12, 15, okay, 18, 21, 24. So when this 24 is being
Sir, when rear equals to front -1.
Front is pointing towards this and rear is pointing towards what? This one? Yes or no? Rear is supposed to point towards the last element. So when 24 is inside,
yes,
rear is pointing towards this location. And if you display, so starting from front, ending with rear, it is displaying all the contents. That is true. So this is the scenario. This is the picture when circular queue is full.
So rear equals to front -1 হবে কি?
হ্যাঁ?
তো বলছি rear equals to front -1 হবে কি? তখন মানে ওই কন্ডিশনটা চেক করতে হবে ওভারফ্লো।
ভুল ভাল বকে যাচ্ছে খালি। কোনো কনসেপ্ট নেই মনে হচ্ছে এতদিন ধরে পড়াশোনা করছো। What is the value of front? Tell me. তারপর করব front -1. What is the value of front? এই দুটো বাসতে গেল।
ampersand q0
ampersand q0 একটা एग्जांपल নাও। মনে করো এর অ্যাড্রেস হচ্ছে 880, এর হচ্ছে 84, এই করে যাচ্ছে। এটা অ্যাড্রেস কত হবে? কে বলবে?
ampersand।
হ্যাঁ বলো। ভ্যালু চাই, ভ্যালু কত? এটা যদি 80 এটা 84 হয় তাহলে এখানে এই এলিমেন্টের অ্যাড্রেস কত হবে? কে বলবে?
স্যার 108।
108 কি করে 108 আসছে বলো?
প্রত্যেকটা তো সাকসেসিভ মানে 4 বিটস করে আমরা অ্যালট করছি। তো 80 থেকে শুরু হয়েছে, 8টা আছে। তো 80 প্লাস 24, তো সরি না 80 প্লাস 24 না, এক মিনিট
বলো।
ইয়েস স্যার, হ্যাঁ স্যার এই ফর্মুলাটা রাইট। স্যার আমি এমনি নরমাল জাস্ট মানে অ্যাড করে বললাম, বাট ইয়েস এই ফর্মুলা দিয়েও হবে।
88, 92, 96, 100, 104, 108. How you are getting that? So let's say, so this is the base address of the array or the address of the zeroth location. ঠিক আছে? 80, and then plus size of the data type of that value you are storing in this array. Let's say that is 4 bytes multiplied by the index of the last element, that is n-1. So 4 into
sir 80 plus 28.
No,
4 into 7.
Sorry, not index. Here n is the number of elements of the
so number of elements 8 আছে, 8 minus 1 7 into 24.
So 8 minus 1 7, 7 4 ঠিক আছে? 108.
Yes.
That's the formula. So this is the 108. Now tell me what is the front value? 80. So if you do 80 minus 1, what does that mean? 80 minus 1 means what? 80 minus 1 into 4. Okay, That means it is giving us 76. This is giving us 76 answer. Now tell me, what is the value of rear? It is pointing towards 24. That is the seventh element. Means here it is 24.
108.
Yeah. So rear is actually equal to 108. Swapnil, কোথায় গেলে?
হ্যাঁ স্যার দেখছি।
So rear is actually 108. Front equal to 7. If you do front minus 1, it will give you 76. So you check whether rear has become 108 or not. If rear has become equal to 108, that means the circular queue is full. Then it will go towards overflow. That is the answer. That is the condition. So do you know the address 108? No.
Ampersand CQ7.
But this formula you know. So if rear becomes equal to the base address, how can you get the base address 80 ampersand of Q0? Ampersand of Q0? Yes or no?
Yes, sir.
তাহলে the ampersand of Q0, if rear has become equivalent to ampersand of Q0 plus size of into n minus 1, where n is the number of elements, then you will understand that the circular queue has become full. So it will go now towards under overflow. That's it. Overflow condition হয়ে গেল. Where we have to do that during insertion here. So if rear has become equal to the ampersand Q0 plus I don't know, it varies from machine to machine. In my machine it is 4 bytes. In some machine it may take 2 bytes. So I can't multiply 4 only here. It is machine dependent. So size of the data type of int and then star. How many? What is the capacity of the array?
8.
Let's say capacity. So total this thing I'm putting inside a bracket. Yeah.
স্যার অ্যারেটা সিকিউ হবে অ্যারেটা।
স্যার আমরা তো ক্যাপাসিটি নিইনি কোনো, স্যার আমরা তো ফিক্স সাইজ নিয়েছি একটা।
কোনো ব্যাপার না, নিয়ে নিচ্ছি।
হুম।
দেখতে ভালো লাগবে। পরে কাস্টমাইজ করতে আরো ভালো লাগবে, সেই জন্য এটা নিলাম। এনিওয়ে, ঠিক আছে, তো হয়ে গেল। So if it will reach, if this condition is satisfied, then it is overflow. Printf যেমন তুমি লজিক চাইবে সেভাবে তুমি কোড করতে পারবে। That's it. Well, return 0 করে দিলাম, তাহলে ফার্দার অ্যাক্সেস হবে না। হয়ে গেছে, ঠিক আছে। তাহলে ওভারফ্লোটা বললাম যে কখন ওভারফ্লো হয়ে যাচ্ছে, এটসেট্রা এটসেট্রা। But you know, this is the simplest case we have understood so far. Okay, insert করে করে যাচ্ছ, সব করে দিলে ইনসার্ট, দেন ডিলিট করে করে যাচ্ছ। মানে কি, ওটাকে যদি গ্রাফিক্যালি এইভাবে যদি করা হয় তো দেখতে এরকম লাগবে। ইনসার্ট করে যাচ্ছ, ঠিক আছে, ডিলিট করে যাচ্ছ, এরকম হচ্ছে কেসটা। So it will not be a problematic situation. But if you do insert and then delete, then again insert, and then delete, then বুঝতে পারছো সার্কুলার কিউটা কিভাবে ঘুরছে? এইটুকু জায়গা এক্সিস্ট করে। Then again insert, let's say 3 elements inserted, then 2 elements, 1 element deleted, then 3 elements inserted. See, we have crossed, we have started here and insert delete, we have done one full revolution, completed one full revolution. But still the circular queue is not full. Then 3 element deleted. This is the beauty of circular queue. We have not verified our code with these test cases.
স্যার মানে ক্যাপাসিটির মধ্যে হলে আমরা যতগুলো করতে পারবো, মানে প্রোভাইডেড ডিলিট করতে থাকি।
এটা এইভাবে ঘুরছে, সব এখনো কিন্তু এমটি হয়নি। তাহলে এই সমস্ত টেস্ট কেসে কি আমাদের কোডটা ঠিকঠাক হচ্ছে তো? So we need to validate that thing. So we will discuss about these situations, these test cases in the next class. This is a very beautiful thing. Okay, and once we satisfy all those test cases in our using our code, then I shall introduce you one very good problem which I have prepared the question. I have prepared the question and gave the students in the last year second class test revised question paper. Yes, it's a very beautiful problem, very standard problem. Okay, so that those two topics we will discuss in the next class. I hope that you liked this topic today. ঠিক আছে, কোডটা শেয়ার করে দেবো, প্র্যাকটিস করো বিভিন্ন রকম দিয়ে, পারলে আপডেট করো, আপডেট করে করে আরো মডিফাই করো। এটা এখনো জেনারেলাইজ হয়নি, আর একটু জেনারেলাইজ করতে হবে, একটু সুন্দর করতে হবে। ঠিক আছে?
ওকে।
So as we have taken front and rear as pointers, so we are facing little difficulty. So if you take front and rear as normal integer pointers, okay, which I do not recommend, there you may have to bother about the indices of the array elements, and that is problematic. If you don't handle the indices properly, problem will arise. And not only that, it is also some little bit of disadvantages. Means if you do front and rear as integer variables, what you have to do, you have to actually if you pass those front and rear variables as arguments through function calls, what is happening, you are actually doing extra memory allocation. That means in terms of space complexity, that is not expected. So that's why we require pointers. Okay? Anyway, so we will discuss more about on the next class. Let me stop here, and if you have any doubt, you can ask me, and let's close the class.